So remember, the more practice we do on these, the better we'll get. But let's take a quick peek. This first one's a quadratic. Notice it's in factored form right now, and they're asking us to graph it. So what do I know? If I look at a factor of x plus 5, I know that the x-intercept is going to be at -5 by zero product property. And if the factor is an x minus 4, I know the x-intercept is going to be at +4. So 1, 2, 3, 4, and -5 are my x-intercepts of this graph. Let's go put the 5 markers all the way around. Actually, I'll use red for that. Okay. After the x-intercepts, we can get the y-intercept. So I can, for the y-intercept, the x is 0. I can plug in 0 everywhere that there's an x. And that's going to leave me 5 times -4, which is -20. So 0, -20 means, do I want to leave this scaled the way it is? No, it won't fit. So I have to adjust the scaling on this axis to maybe be scaling by 5s, 5, 10, 15, 20. So this y-intercept would be at 0, -20. And so now I'm telling this that I'm scaling by 5s. Okay, let's write that in over here, 0, -20. Now, what else can I use to graph this? I need to know where the middle of these two dots are. So notice that this is 4 in this direction and 5 in this direction. So the vertex is actually in the middle right here. It's not going to be a whole number. So that's, to get the vertex, I can do a couple different things. I can do the average of the roots. So -5 plus 4 is -1/2, which is -1/2. That means that my line of symmetry is going to go straight down the middle here. And then I can go plug in 1/2, f of -1/2, and I get -1/2 plus 5 and -1/2 minus 4. So -1/2 plus 5 times -1/2 minus 4. This is going to be 4.5 times -4.5. So I'm grabbing my calculator to do that. 4.5 times 4.5 is 20.25. So -1/2, 20.25. That's a negative. Yuck. So if this down here was a -20, it's going to be just below that. And so there's my vertex. Connected, there's my graph. Last thing we put is the line of symmetry straight down the middle. All right, so that's when it's in factored form. Easy to get the intercepts, not so easy to get the vertex. Next, we have an exponential. So do a quick table for this one. How do I know it's an exponential? Notice the power. So if I plug in 1, 2, 3, we'll just throw in a couple dots. This is a function that starts at 5 and is multiplying by 2 each time. So 10 times 2 would be 20. So we're going to go 1, 5. We're going to count by 5s on that axis again. 2, 10, 3, 5, 10, 15, 20, and there's my curve. So here we're going to count 1, 2, 3, 4, 5 marker. Here we're going to count 1s. All right, x-intercept is none. That curve never hits the x-axis. Y-intercept would be at 0, 5 halves. So going this other direction at 0, comma 5 halves. If I also wanted to plug in 5 times 2 to the 0 minus 1, it's 5 times 1 half, which is 5 halves. You can do that in a calculator as well, known as 2.5. That's this guy right here. All right, next one's just a linear. This is touching right here at the critical point of negative 3, 0, 1, 2, 3. And then it has a growth of down 2 over 1, down 2 over 1. There's my slope. So my M is negative 2. My critical point is negative 3, 0, also known as my x1, y1. And I graphed it, connect it, draw the arrows. And make sure you labeled and scaled. All right, this is just a parent stretch parabola shifted down 4 from the original spot. So down 1, 2, 3, 4, there's my vertex, and then its growth is 1, 1, 2, 4, 3, 9, etc. There's my little parabola of the x squared. So what's my x-intercept? It touches at negative 2, 0, and 2, 0. What's my y-intercept? It touches at 0, negative 4. Another way to get these x-intercepts is if I were to solve that quadratic by setting it equal to 0, adding 4 to both sides, and getting 4 equals x squared, x equals plus or minus 2. And so there's my two roots right here and right here for x equals 2 and negative 2. Oh, and over here, my x-intercept is at negative 3, 0. That was my critical point, and my y-intercept is at negative 1, 2, 3, 4, 5, 6. Forgot to put those on there. Okay, how'd you do on graphing those 4 functions?